Welcome to Cognitia in Concise. Today we're asking a simple question with an absurd answer. What is the largest star in the universe, and why is it that big? To understand that, we first need to understand what stars actually are, and what almost stars look like. We begin with Earth, not to learn anything, just to get a sense of scale. Earth is tiny. The smallest objects with star-like properties are gas giants like Jupiter. Jupiter is 11 times wider than Earth, 317 times more massive, and made of nearly the same material as the Sun. But it's missing one thing. Enough mass between planets and stars are brown dwarfs, often called failed stars. They have between 13 and 90 times the mass of Jupiter. Even smashing 90 Jupiters together wouldn't be enough to create a real star. Adding mass to a brown dwarf mostly makes it denser, not much bigger. Some weak fusion reactions can occur, causing them to glow faintly. But they can't sustain hydrogen fusion. A true star forms when gravity compresses gas so intensely that hydrogen fusion begins in the core. Hydrogen fuses into helium, releasing enormous amounts of energy. Gravity pulls inward, fusion pushes outward, and this balance creates a stable star. Stars that fuse hydrogen are called main sequence stars. They spend most of their lives in this phase. The smallest of them are red dwarfs, barely massive enough to sustain fusion. They are small, cool, and dim, but incredibly long-lived, lasting up to 10 trillion years. Red dwarfs are the most common stars in the universe. One of our closest stellar neighbors, Barnard's star, is a red dwarf and can't be seen without a telescope. Stars like our Sun are more massive and burn much hotter. The Sun contains 99.86% of the mass of the entire solar system and will shine for about 10 billion years. Though it is only about 7 times more massive than Barnard's star, it is hundreds of times brighter as stars become more massive. Small increases in mass cause enormous increases in brightness. Sirius, the brightest star in our night sky, has only twice the Sun's mass, but shines 25 times brighter. Even larger blue stars can shine tens of thousands of times brighter than the Sun. But they burn their fuel so quickly that they live for only a few million years. The most massive known main sequence star is R136A1. It has over 300 times the mass of the Sun and shines millions of times brighter. Yet, it is only about 30 times wider. Stars like this are so extreme that their radiation blows away surrounding gas, preventing them from growing much larger. To become truly gigantic, stars must leave the main sequence. When a star runs out of hydrogen in its core, the core contracts and heats up. Fusion accelerates, pushing outward and causing the outer layers to swell. The star becomes a giant. Our Sun will eventually expand to around 200 times its current size. Swallowing the inner planets, the largest stars in the universe are hypergiants. Massive stars in their final stages of life. Blue hypergiants are enormous and violently unstable, losing mass through powerful stellar winds. Yellow hypergiants are even rarer, short-lived transition phases between other stages. Only a handful are known. The largest stars of all are red hypergiants. They are so vast and diffuse that gravity at their surface is barely able to hold them together. Measuring their size is difficult, and estimates often change as instruments improve. The largest star currently known is Stephenson, 2-218, at its upper estimates. It is over 2,000 times the radius of the Sun and shines nearly 500,000 times brighter. If placed at the center of our solar system, it would engulf Saturn's orbit. Traveling around it at the speed of light would take almost 9 hours. Stephenson, 2-218 is actively shedding its mass and will likely shrink, heat up, and eventually collapse. Its life will end in a massive supernova, scattering heavy elements into space. Those elements will form new stars, new planets, and eventually, new life. Every atom in your body was forged in stars like these. They live fast, die violently, and make the universe possible. This is the cycle that lights up the cosmos. You're watching Cognitia in Concise. Like, subscribe, and stay curious.